Let's look at problem 1658, minimum operations to reduce x to 0. So here we are going to provide a solution using dictionary and check for partial sums after we transform this problem. So here first I'll walk through the statement of the problem, and then we specify the main idea, and finally we write code and emphasize a subtle point. First, let's look at the statement of the problem. So we are given an integer array called nums and an integer x. So in one operation, we can either remove the leftmost or the rightmost element from the array nums and subtract its value from x. Notice that during the process, the length of the nums change. So we are required to return the minimum number of operations to reduce x to be exactly 0 if it's possible. Otherwise, we are required to return -1. So let's look at the constraint of the problem. The first constraint is that the nums is not empty, and its length can be up to the order 10 to the power 5th. And again, the latter speaks that, so we cannot refer to pure brute force to approach this problem. So the second and the third constraint is about the range of elements in nums and the range of x. So with that said, let's look at the main idea of the problem. So here the main method, the method we are going to use is dictionary and check. So here we check the partial sum. Some people call this prefix sum or postfix sum, and they also write in two-pointer format in the code. So, but the main idea are the same. So let's first look at the example 1. So here I will use this example, but I will modify a little bit. I will move this 3 in front. So in this way, so for this problem, in order to get this 5, we can choose the prefix 3 and the postfix 2. Then they add up to 5. So actually, this is equivalent to that. So we are trying to reformulate the problem. So because we are looking at this part and this part, so this is the remaining part, which is continuous. So contiguous. So we are going to try to find the longest subarray, which sums to the full sum of nums. So that is sums of nums minus this x, right? So the minimum number of operations, will be the total length of nums minus the length of the subarray we find, right? So once we realize this point, then a solution actually is routine. So in other words, we're going to use running partial sum. So the idea is simple. For example, in a previous index, so for example, we have G, which corresponds to a partial sum Fg. And if we have another index corresponding to a partial sum Si, then we just need to check if Si minus Sj equals the target we're going to use. Let's call this one the goal. If equals the goal. So in other words, the corresponding length for this subarray actually is I minus j, because the subarray with the correct sum is starting from I plus 1, then ending at j. Oh, here, let's adjust a bit. Starting from j and ending at I. So with that said, let's look at the code. So again, we can first make some preparation. So the goal we're going to use is the sum of nums minus x. So this is what we are going to get. So before we do anything, let's try to do an edge case. So this is actually an important edge case. So if its goal equals 0, so in other words, the total sum of nums equals exactly the target x. So we're going to return, in this case, the length of nums. So in the general case, that is step 2, we're going to check to do the dictionary and check step. So for that, let's first initialize a dictionary, so which stores the partial sum and the earliest index this partial sum appears. So in order to deal with the case with 0, so we use a dummy index. For example, if there's a full sub array starting from the very beginning, so it's corresponding to this case. So now I get we also need to find a partial sum, running partial sum. Let's call it 0. Then we are ready to move into the for loop for I, y in enumerate nums. So in each of the step, we are going to update the partial sum by the current number. Then we will do the check step. What we check is that if partial sum minus goal is in the dictionary. So if so, let's check the index for convenience. So let's see. This means that the subarray starting from g plus 1 and ending at I has some goal, which is what we desire. So now, so we can update a length. So before we do that, let me specify a length. So we can make it, because we want to find the longest one. Let's do it -1. That's sufficient. So we just update this length by the max. Right. So the length of the current subarray is I minus j minus 1 plus 1. Right. So then we can do this. So once we are done here, so another thing is that we need to update dictionary. So if a partial sum not in D, so in other words, it hadn't appeared before, so we need to update this. Then I, the index I, is the earliest index that this partial sum appears. So once we've done this, so we are ready to return the result. So as required by the problem, if length is -1, we're going to return -1, right? Otherwise, we are going to return the length of nums minus the length of the longest subarray, right? So with that said, let's check several special examples. Let's run the code. So this is for a special case, actually, we cook up. So in this case, so the total sum is exactly the x, which is treated by this edge case. So let's look at this example. So yeah, we will have 5, and so we are using this 2 and 3. The longest subarray of the corresponding to the complement is 114. Let's look at this. We should return -1 in this case. Okay, so let me see more about this special case. So if we do not do the edge case, and then we write this code like this, it will not pass the generic case. Let's first check the generic case to make sure it works. So now if we do not treat this edge case, so then we try to run the code. It will not pass this case. Actually, this case corresponding to here, corresponding to we have array which has x is exactly sum of the array. So in this case, you see this for loop will not treat the case, but if you place this part, we copy this one in front before the check, then we comment this up, so this will work. But in the strict sense, this logic is not that right, because from the assumption of the problem, so all the elements are non-negative, and in this case, the goal is 0. So then we first update the dictionary, and then we do this check, partial sum minus goal, that is partial sum in D. So they update, but this is 0, right? Always 0. So though this passes all the test cases, in a strict sense, this logic is not perfect. So overall, we need to do the check first and then do the update. So check and update. So we also pay attention to the edge case. So I would personally, so we transform the problem, then treat the edge case, and then in the dictionary and check step, we first do the check and then do the update. I guess this is the correct logic. So of course here, if we want to return, let's write it shorter, so we can return length of nums minus ls if ls is not equals to 1, like else -1. So we can do this submit. So that's about it. Thank you.